We're going to now take the derivatives of inverse trig functions. I'm not going to go into a lot of detail on the inverse trig functions because that would be an inverse, not an inverse strictly, but a trig lecture series, which I'm going to do after this one, but not after this video, but after this series. So at any rate, you might need to go back and review your trig, possibly college algebra, if you don't remember about inverses, right? So remember, for inverses, the original function has to be 1 to 1. So I'm going to give you these little hints. The original function has to be 1 to 1. And for the sine function, as you can tell, this function's not actually 1 to 1 because 1 to 1 says it passes the vertical line test and the horizontal line test. Passes the vertical line test, the one that goes like this, but it does not pass the horizontal line test. So I like to refer to it as cheat in a legal way. All right. So what they went, okay, well, let's just pretend that sine doesn't go on forever. And let's just take a part of sine. And if we only look at a part of sine, then we can say that for that part, it's 1 to 1. So I'm kind of think it's funny that math people find a way to cheat. Okay, legally cheat. All right, so what they do is they say we're only going to look at this section right here. That way we can get the negative sign numbers in and the positive sign numbers in. And then remember, the inverse was symmetric with the original function about the y is equal to x line. So it would be symmetric about this line right here. So they did the same thing with cosine, right? Because again, cosine passes the vertical line test, but not the horizontal line test. So they went, let's just look at only one part, pretend it's only one part long, and then we can say, well, we'll talk about the inverse for that section. So for cosine, they could get the positive and negative numbers in this area right here. And then they find the inverse. Let's go back and look at your trig book. And the inverse, which is the blue part, is symmetric with respect to the y is equal to x line. And when I plotted this on Desmos with the tangent function, it just plotted them all. So I thought, oh, why not? We'll just leave them. So they ignored all of these pieces. And then they did the inverse with this piece right here. There's all the positive and negative numbers. And so the inverse for that section is this. Now, really they didn't cheat, but it makes me smile to say that. It makes my students smile. So it's kind of worth it to just sort of take that and stretch it out to some abstract of let's just look at one section. So they do define it as that. So in mathematical terms, it's defined. So you ignore the rest. But I just consider it cheating because the original definition to find an inverse is that entire function has to be that way. So it just always makes me laugh. Okay, so neither here nor there, right? So if that's just really leaving you crazy, then you might want to go back and look at your trig. So if you've forgotten how inverse functions work, they're normally trying to find the angle, right? If you say sine of 60 is the square root of 3 over 2, so the inverse sine of the square root of 3 over 2, well, there's actually two quadrants where that could happen, but we would reverse this one back to 60 since we know that's where we started. All right, so that's what it's doing. And some of y'all may have learned it instead of saying inverse sine with this -1 right here. Some of you may have learned it or be more comfortable with arcsine. And this would be arccosine, arctangent, arccosecant, arcsecant, and so forth. All right, now we'll kind of go back and forth a little bit on that. The one thing you have to really watch out for if your book or your professor uses this form for the derivatives is this x right here is in there. And so if it's anything other than an x, you have to loop back in and take the derivative of the inside. So some books, which I actually like, use u, but doesn't seem to be so many of those. So this over here would be u squared, and I think the u helps people to remember to loop back in there and take the derivative. So I encourage my students that when you're writing these down, you put the parentheses around whatever the x is, knowing that whatever this is going to go in here, right? And you'll see me do that, but that's just sort of it's sort of self-defense for me, okay, because when I'm grading the students' papers, they make fewer errors if they put the little parentheses there and keep track that whatever is here goes in there, because sometimes this square gets lost. And anything that is self-defense for me and makes grading easier makes the students' grades higher, not because I'm a happier camper, but because they get it right. Okay, because then they don't lose things. So I encourage you to be doing the same thing, and I'll try to reinforce that. So let's try one, and if we have y is equal to the inverse tangent, I want to make this a little bit more difficult. Let's do x inverse tangent of the square root of x. Now, this could also be y is equal to x arctan of the square root of x. I don't actually prefer arctan because it's just longer to write, but some students like it, some teachers like it because this -1 is not tangent square root of x to the -1. Remember if we had something like sine squared x, this was actually sine x squared, right? This was a shorthand for doing, let's square the whole thing. That's not how this works, okay? So if you had sine of -1x, this -1 does not come out there, all right? So if you're going to be thinking that, you might want to self-defense use arctan, but use whichever one makes you feel better. And of course, use the one that your teacher prefers, because as you hear me say once in a while, I don't actually say it out loud too many times, the person with the red pen wins. Okay, so if your teacher is the one that's grading your paper with a red pen, whatever format your teacher wants, that's what you should do. All right, now they don't win if it's morally or ethically illegal or just flat out unethical. But if it's a matter of this is the format that I want, the one with the red pen wins. All right, now, so this problem is actually the product rule, right? Sometimes they get lost in there. There's so many letters. So this is the product rule. So it's the first times the derivative of the second. So you look over and you try to find the one that's the tangent. So the derivative of the inverse tangent of x is 1 over 1 plus x squared. And I'm making a video that's going to be a partner to this one that's all the proofs. So look for the link in the description that's down below. All right, so remember this x right here goes, whatever it is, goes in right there. And if it's anything other than an x, you have to loop back in and do the chain rule. Well, all right, so what are we getting ready to do? We're getting ready to take the inverse tangent of x, right? So we have the first times the derivative of the second. So it's 1 over, and in our case, we have the inverse tangent of the square root of x. So the square root of x is going to go right there. Okay? So it's going to be 1 plus, and we're going to put the square root of x right here and square it. You with me? Okay. So whatever is right here goes right there. Now, what's going in here, this part right here, is not simply an x. It's the square root of an x, which is itself differentiable, right? So we're going to loop back in and take the derivative of the square root of x. And the square root of x, because remember we're taking the derivative of this part in here. So the square root of x is actually x to the 1/2, right? So we're going to take the derivative of that. Now this all gets multiplied on the outside. It's not down underneath it's not down underneath here, okay? It's off to the side. So the derivative of the square root of x, or x to the 1/2, is you bring the power down, leave the inside alone, take 1 off the power, right? And then you would loop back in and see if there's anything in here, but the derivative of x is 1. All right, plus the second times the derivative of the first, which is 1. All right, so let's talk about what we've got here, right? So what we've got is this x goes up here. We have 1 plus the square root of x squared is x, okay? And we've got this 1/2, so I've got a 2 down here. All right, so far so good. And I've got an x to the minus 1/2, which is 1 over the square root of x. Okay, do you see where everything went? This x came up here. This 1/2 came down there. This x to the 1/2 minus 1/2 came down there as well. Okay, now you may be able to do this faster, but I'm just kind of going slow. And 1 times anything, it's itself. Okay, and this square root of x will cancel into this x, leaving you a square root of x. Dropped off my 1 there. Okay, now this is technically okay. Forgot my prime up there. Oh my goodness, that was bad. Okay, so got so busy talking to you about inverse tangents, I forgot to write my y prime down. Now, this is, sorry, but that's strictly true. All right, so nothing wrong with this, except that at the beginning it actually is a product. We've now acquired 2 separate fractions. So depending on your teacher, and I'll be honest with you, I am really picky, right, about the fact that when you take the derivative of something, you need to get it back into the form that it was when you started. So if it was a product, you need to get it back. If it was a single term, you need to get it back to a single term. But on these inverse ones, sometimes they're so crazy, okay, and they get so many moving parts that I let my students off. And on these, I don't really expect you to clean them up. I don't know what your teacher wants. Okay, so if your teacher still wants you to clean them up, then what you would need to find is your least common denominator is 2, 1 plus x, and you would multiply this by 2, 1 plus x, top and bottom, in order to get a common denominator and pull them together. All right, so that's totally up to you. But you need to get familiar with your teacher. Watch what your teacher does in their demonstrations. Even if what you're doing is an online course, they probably have videos. So if they keep going, you need to keep going. And if they stop here and say, really, I'm just thrilled that you can get all these moving parts together, so you can just stop there, then just stop there. Okay, let's do another one. So y is equal to the arcsine, or inverse sine, of 2x plus 1. All right, so over here, the derivative with respect to x of the inverse sine of x is 1 over the square root of 1 minus x squared. Okay? Now, as you can tell, let's go back over here and look. It's really easy to lose things and suddenly your entire problem's wrong. So, like, if you look at this one and this one, they both have the square root of x squared minus 1 with it. One has an x on the bottom. What is it? This one has a minus. This one has a minus. This one has a minus, right? So if you forget a minus, or, if you forget a minus, you're suddenly doing tangent, okay? So don't miss these little tiny details. So what you might want to do is to write them down next to the problem you're doing, or not, depends on how much time you have. All right, now here we go. So what I'm going to put in here in place of this x is this 2x plus 1. All right, so what I have is y prime, because this time I remembered my y prime. And for inverse sine, it's 1 over the square root. Don't forget your square root. Sometimes students get busy and forget. 1 minus whatever this, let's call it u. This u is right here, and that is for u, 2x plus 1. And then you're going to square it. So you square it because that's what it says to do. And then you loop back in because this is not just an x. So what is in here is 2x plus 1. So it's not just an x. You're going to loop back in and take the derivative of the inside and get 2. All right? So y prime is 1 over, and then the only thing that's here is you have to clean up the bottom sometimes. So let's look at that. So you'd have 1 minus, and 2x plus 1 squared is 4x squared plus 4x plus 1. I'll bring the 2 over in a minute. Okay, so then you have the 2. So you have 1 over, and then, well, let's just write it out. 1 minus 4x squared minus 4x minus 1. So you, times 2. You have, let's go ahead and clean, because apparently I'm going to drop that off. Okay, so 2 times 1 is 2 over, sometimes you just have to laugh at yourself. Okay, if you can't find any humor in the math that you're doing, you can always find humor and laugh at yourself about something that you just almost did or just did. Okay, so I could factor out a -4, I guess, because these ones are going to go away. And I have -4 times x squared plus, I guess I could do an x too. Let's do it 4x. Let's live dangerously. So we're going to factor out a -4x from this part right here. So that would leave me x plus 1. All right. Now I can't get out a -4 because that, well, I could. I mean, that would be an imaginary number, but these are actually functions that we would graph, so let's not go there. All right. But I could factor out a 4, right? So what I'd have is 2 over the square root of 4 is 2. So I'd have a 2 out here, and my negative's still there, and I have this. Okay, you doing okay? Okay, so then these twos cancel, and you have 1 over, don't forget you still have 1 on the other side of the fraction bar. Grandma parentheses. X plus 1. Okay, all right. Not horrible, is it? Okay. So let's see. We did one just like that. Okay, so let's not do that one. All right, so let's do y is equal to the inverse cosine. They could have said arc cosine, right, of x squared. Now we've done a couple of these, and I'll write this over here. The derivative with respect to x of the inverse cosine of x is the -1 over the square root of 1 minus x squared. Okay? Now I want you, we've done a couple. I want you to stop. I want you to put all your bits and pieces where they belong, right? You might even want to work all the way to the end, but at least get this next line, where you're going to have to decide what goes where and where all your little, problems are that you have to clean up. So stop for a second or 2 or 3 and get this next part done, and then turn it back on, and let's do it again and see if you're right, because it would be more beneficial to you to see if you've got the hang of this now than to see if you've got the hang of it on the test. Okay? So give it a shot. See what happens. All right. Now, hopefully you're back. And what you decided is that what's going in here that goes right here is this part, which is x squared. So what's going in here is x squared. And so what you literally have is y prime is, and you'd have the negative, don't forget the negative, 1 over the square root, because that's what it says, 1 minus, and you put the x squared in there, because that's what you substituted in, and then you have a square. So did you get the two squares? Okay. Sometimes because your brain just saw a square, it thinks it already did the square. So hopefully you got the two squares. And did you remember to loop back in and get the derivative of the inside? So all of that has to do with this x squared right here that went in right there and that you took the derivative of. Okay, now if you got all those pieces, you've got this down. Now you just have to keep your mind on task all the seconds you're doing this, you're great. Okay, so when we clean this up just a tad bit, I get the negative 2x over, and you actually put the negative on the outside, 1 minus x to the fourth, and there really isn't anything to do. So let's put a negative out here. And this would be this answer. Okay, let's try another one. Let's do y is equal to the inverse cosine of x squared squared. Okay, now this 2 does not see that 1. All right, it's not going to make it a minus 2. Here we go. So y prime is, and we had the derivative with respect to x of the inverse cosine is minus 1 over the square root of 1 minus x squared. So in this case, our inside is still x squared, and this is x squared in here, and I dropped my x off there. All right, doing okay? But what we have is a power rule on the outside, so we're going to do the chain rule. So we bring the 2 down. We leave the inside alone. Okay, so this is the inside. We take 1 off the power, and then we loop back in and take the derivative of the inside. So we would have, and the inside is this part right here. So you would have this negative 1 over the square root of 1 minus whatever x is, which is this part, again, squared times 2x. Okay? You may need to watch that again, or maybe not. So when you get this cleaned up, it turns out to be minus 4x inverse cosine of x squared over the square root of 1 minus x to the fourth. Okay? I think this next problem is kind of cute. So remember, this could be arcsine or inverse sine. So inverse sine of x plus the square root of 1 minus x squared. And the derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. So you might be going, hey, look, might be something here. And this is just an x. So this x is going to be comparable to this x, which goes right in here. So we're not going to have to loop back in, right? So we would have y prime is, and you would have, oh, I left part off. There's supposed to be an x right here. That's what made it so cute. Okay, so we have the product, all right? So let's go back. So we have the product. So it's the first times the derivative of the second, which is 1 over the square root of 1 minus x squared. Okay, plus the second times the derivative of the first, which is 1, plus, now we're going to take the derivative of 1 minus x squared to the 1/2, right? So you bring the 1/2 down, leave the inside alone, take 1 off the power, loop back in and take the derivative of the inside, okay? So this is x over the square root of 1 minus x squared. This right here, if you look down at this end piece, this 1/2 cancels this 1/2, okay? This x right here is going to go on the top, and this 1 minus x squared to the negative 1/2 is going to pull down into the denominator. So I'm going to pull this piece over here, and it would be minus x over the square root of 1 minus x squared. That's kind of cool, okay? And the only thing we've got left is the inverse sine of x. So this is going to come down here. I just wanted you to see these two together right there, and they go to 0. So the answer is the inverse sine of x. I kind of like it when things like that clean up. They make me smile. They also make me kind of nervous because I'm like, did I just do something I shouldn't have done? Okay. Now, so let's do y is equal to the square root of x squared minus 1 inverse secant of x. And the derivative with respect to x of the inverse secant is 1 over x square root of x squared minus 1. So the thing that is important here is whatever this x is there, it's going to go here and it's going to go here. It has to go in both places. So this is going to go on the outside down here in the denominator, on the inside of the square root in the denominator. And then if it turns out to be something other than an x, you would have to take the derivative of it out here. So it goes in two places. Now this one is just an x. So that is not going to be a problem. And it's the product rule. So y prime is the first times the derivative of the second, which is 1 over x square root of x squared minus 1. Okay, plus the second times the derivative of the first, which is x squared minus 1 to the 1/2. So this would be bring the power down, leave the inside alone, take 1 off the power, loop back in and take the derivative of the inside. Okay, so this is this square root of x squared minus 1 cancels this one. And you've got 1 over x plus, and this 2 is going to cancel this 2. All right, and so what you've got here is x inverse secant of x over the square root of x squared minus 1. See this x right here? It comes over with this secant of minus 1, secant, inverse secant of 1. Now, for me, all right, like I said, to be honest, I let my students off the hook for returning it to the original form for these because I'm just glad they got all the moving parts into the right place. And so, but if your teacher wants it back to where it looks more like a product or like a single entity as opposed to two fractions, then you would have your least common denominator is x times the square root of x squared minus 1, right? So this would be the square root of x squared minus 1 over x times the square root of x squared minus 1 plus x squared inverse secant of x over x square root of x squared minus 1. So you would have x squared minus 1 plus x squared inverse secant of x over x times the square root of x squared minus 1. All right. Now, I don't know about you, but I'll show you the two forms so you can spot them. Okay. I don't think either one looks much better than the other one. So, whatever your teacher wants is what you have to do. Okay. Or in your case, it might be your computer program homework software. I don't know. But keep in mind, let's look at this one really quickly. If this had been the inverse secant of, let's say, 2x, okay, and you wanted to take the derivative of that, then it would be 1 over, and you would put you're going to put your 2x where this x is and the other x is. So you would have 2x square root of 2x squared minus 1, because you're going to put that in everywhere you have this little circle. And since what's in here, right there, is not just an x, you're going to loop back in and take the derivative of the inside. Okay, so please keep in mind that if you have something that just has an x out here, it's whatever you had in place of x. Okay, the x, this x right here is just a placeholder for whatever it is that your particular problem has. Okay, hope that helps. There'll be some problems in the description down below, but there'll also be a link to the proofs for these. And I wish you luck with these. Just be really careful what part goes where, and I strongly suggest that you do something where you circle these bits here that you're going to replace with what you're going to replace with, so you sort of have a destination in mind. Okay. Don't forget to like the videos or subscribe. That would be very helpful. And I'll see you at the next video.